Okay, now next one is cells are in series combination. Series combination of the cells. Series combination of cells. I will take two cells. See one cell of EMF E1 and its internal resistance is R1. This is one cell. Compulsory you have to draw the imaginary circuit like this. Another cell is there of EMF E2 and its internal resistance is R2. And why we will connect the cells in series combination to produce high potential. For example, your vehicle, car battery is there, bike battery is there. If you take any car, battery, how many functions are there? To just start the car only, we use the battery. After that, remaining thing, diesel, petrol will take care. But to start the car, to ignite the engine, to burn that petrol or diesel, lot of high voltage is required. Understood? 200 volt required, but one cell is 50 volts. How many cells will connect like that? 4 cells will connect in series combination. I mean, to deliver more energy in very less time, you have to use which combination? Series combination. Now, when we'll use cells in parallel combination? Parallel combination. Why? You don't need to supply more energy. Example, in the functions, some annual celebrations of a school and any big rich fellows marriage function, on the building they will keep the LED bulb connections are there, na? Serial bulb. That is series combination. Why that combination you see in on all household devices, all are in parallel combination only. Every projector, every device connected in which combination? Parallel combination. Why we will connect parallel combination? Less voltage, but for very long time. But series combination, why? High voltage, less time only. That's what battery will be drained very quickly. Are you understanding? Old 15 years, 20 years old cars, example, my car is there. Always it will drain. Why? The terminals of the battery getting rusted. Spare parts also will not available. Continuously reaction with oxygen, oxidation taking place. What oxygen molecules will do? Discharging taking place. The what you charged the battery will be discharged into the gas molecule. So it will drain quickly. Are understanding? So let us see how it will function series combination. What you need to connect? One bulb you have to connect, na? Bulb is nothing but what you tell me? Electric resistance capital R or external resistor. Now these two cells are acting like a single cell only, no? So that single cell is called effective cell. Its EMF is A. And these two resistors, two internal resistors are acting like a single resistor. That is net resistance R. Two cells right now acting like a single cell. And it is also connected to the bulb of external resistance. How much? Capital R. In which direction current will go? Always coming out of the positive terminal like this. Here also coming out of the positive terminal like this. Say yes or no. Now tell me how much current is flowing in this circuit. I is equal to how much? Net EMF by net resistance. What a net EMF here? E net and net resistance is equal to how much? R net. So net EMF divided by net resistance how much? Capital R and internal resistance in which combination? Series combination. So R plus R net. Keep aside equation number 1. Is it clear? And next one, I will walk from junction A to junction B to junction C, C to D, and next D to E. And polarity also important to apply the loop law. Big terminal is always plus, minus. This is plus and minus. How current will flow from high to low? Here, how current will flow from an internal resistance high to low? Here also high to low. I will walk from A to B, B to C, C to D, D to E, and finally I will come back to my same position. When I am walking from A to B, potential will increase or decrease? Decrease, minus. What a potential drop across A and B? E1. Next, B to C, what will happen? Increase. How much potential difference? Very good, IR1. When I am walking from C to D, minus E2. When I am walking from D to E, increase, plus IR2. E to A finally, plus I into capital R equal to 0. Loop law, summa, tell me. Any doubt? This understanding this step is very important. If you understand this step, in current electricity, you can do anything. Any doubt, ask me. And now, I will take common. If you take common, what will happen? R1 plus, R2 plus, capital R, and E1 I will take this side, E2 I will take that side. So what will happen? E1 plus E2. So I is equal to how much? E1 plus E2 divided by R1 plus R2 plus capital R. If you compare the equation number 1 with the equation number 2, what is the net EMF of the effective cell equal to E1 plus E2? What is the net internal resistance of the two cells? R1 plus R2. Hereafter, those are standard formula. You must remember at your fingertips. I will write down here. What a net EMF for the two cells? E1 plus E2. What is net internal resistance? Tell me. R1 plus R2. If n number of cells are connected, how will you convert this formula? Net EMF for n number of cells connected, how will you write? E1 plus, E2 plus, and so on, En. What are net internal resistance for n number of cells? R1 plus, R2 plus, and so on, Rn. If all are identical cells means, what a net EMF, tell me? E plus, how many times? N into E, very good. What is the net internal resistance, tell me? R plus, and so on, n times. So, n into small r. What is the purpose of the series combination? Tell me, important note. To give more energy. Which things will give more energy? Tell me. To start a car battery, huge amount of energy should be given in very, very less time interval. That's what, if you open the car battery, all cells are in which combination? Series combination only. Understood? But in the marriage functions, some other function where less light energy required. That, have you seen the chain of bulbs? He said something. Series of bulbs, serial bulbs. LED bulbs are there, na? Thousands of bulbs are there. Simply they will hang on the building. Everyone will understand. Okay, this is guy is rich guy. He is celebrating his daughter marriage very nicely. Understood? Like that, everyone should think, no? Correct or not? Those are in which combination? They will emit very less energy, but should work for long time. They are in which combination? Parallel combination. Are you getting my point here, student? Both required means long time required, big energy also required. Then series and parallel you have to connect. Both combination you have to use. What is the specific reason for series combination? More energy, less time. Parallel combination of cells, less energy, more time. I want more energy, more time means mixed combination you have to use. First, let us try to copy this quickly, and I will explain parallel combination of the cells.
Previous CPT they asked internal resistance.
They asked, it is there in portion? Not there, no? Not there, no? If any things are there, immediately text me, please. I will raise the objection, okay? Only one question, huh?
I don't remember.
Okay, I will check once paper. Abhishek, turn on one light, last rear light only. Max, huh? Okay, so the very next one is which combination? Tell me. Tell me which combination? Parallel combination of the cells. For first, I will take one simple case. Two cells I am taking. One cell of EMF, how much? E1 and internal resistance is R1. And now it is connected to parallel combination with another cell of E2 and its internal resistance is what? R2. They are also in which combination? Tell me. Parallel. Now focus here. Now connected to one bulb. Bulb means what here? External resistance, capital R. Now these two cells are acting like a single cell of EMF. How much? E net and two internal resistance are acting like a single resistor. And now as usually connected to one bulb of external resistance. How much? Capital R. Now in which direction current will come? Current always coming from high potential to low potential, means here plus 2 minus, but inside the internal resistance plus 2 minus. Okay, here also current will come like this. Here how much current will come? Tell me. I1 will come here. Tell me I2 will come. Yes or no? Tell me what is the current here. Tell me in this combination I equal to net EMF by net resistance. Net resistance how much? Capital R plus R net. Keep aside equation number 1. Watch this circuit. I is equal to what I can write? Tell me. I1 plus I2 only, na? What is I1 value? Tell me. This cell is discharging, no? This cell is discharging or not? How we can write I1? Tell me. I'll keep aside equation number 2. This is junction A means this is also junction A. This is junction B means this is also junction B. This is also junction B and this is also junction B. Sir, junction A. My question, what is the terminal potential difference across the first cell? E1 minus I1 R1 equal to terminal potential difference across the external resistance, no? I into capital R, na? Did you understand this step? Really understood or not understood? Here, how much potential difference is there, ma? Here also same potential difference is there, no? This is VA minus VB. Here also VA minus VB. Here also VA minus VB. Same thing I have written. And also E2 minus I2 into R2 also I can write. Now is it clear now? Okay. Now I will equate them only. So E1 minus I1 into R1 equal to how much? I into capital R. This one I will bring this side. This one I will send this side. So what will happen? E1 minus I into capital R equal to I1 into R1. Tell me I1 value how much? E1 minus I into R by R1. Substitute nicely here. Similarly, by using same logic, I2 what I can write? E2 minus I into capital R by R2 I can write, na? Here also substitute. Derivation is not required, just I am explaining. You substitute I value how much? E1 minus I into R, sorry, I into capital R divided by R1. And I2 value substitute E2 minus IR divided by R2. And I know the standard relation. If you simplify small I value, you will get like this. E1 by R1 plus E2 by R2 and whole divided by capital R plus R1 R2 divided by R1 plus R2. Like this you will get if you simplify this equation. This is exactly equal to this equation only, no? This is yes or no? E net by capital R plus R net I can write. Now what is net EMF of this cell? Tell me. I am asking you what is net EMF of the cell standard formula? E1 by R1 plus E2 by R2 whole divided by 1 by R1 plus 1 by R2. One small correction, student. Here I forgot to write 1 by R1 plus 1 by R2 also will come. This is the standard formula. Everyone, I am requesting, kindly remember compulsory at your fingertips. Short technique, which will save your lot of time in exam hall and it will avoid you pressure on your brain also. What a net internal resistance of the cells? Tell me. What a net internal resistance of the cell? Of the cells? Tell me. 1 by R net equal to how much? Tell me. 1 by R1 plus 1 by R net, R2. I have explained for 2 cells only. If n number of cells are there, how will you generalize the formula? Very good. For n number of cells, how will you generalize the formula? Tell me. E net equal to how much I can write? E1 by R1 plus E2 by R2 plus and so on up to En by Rn whole divided by 1 by R1 plus 1 by R2 plus and so on 1 by Rn. This also I am requesting compulsory you should remember. For a number of cells, what is the net internal resistance? Tell me. 1 by R1 plus 1 by R2 plus and so on 1 by Rn. If all are identical cells means for all N identical cells means what?
E divided by
How the formula will come? Net EMF equal to what we can write? E by R plus E by R plus. How many times it will repeat? N times it will repeat. And denominator also how many times it will repeat? N times it will repeat. So N into E by R whole divided by N by R will come. N by R cancels out. So what a net EMF equal to? E only. And what is the net internal resistance? Tell me. 1 by R net equal to how much? Tell me. 1 by R plus, 1 by R plus and so on. N times it will repeat. So 1 by R net equal to how much? Small n by R. So what a net internal resistance equal to? R by N. So these are all the standard results. Compulsory you have to remember. Copy this parallel combination. Now after this mixed combination I will explain. Okay. After doing this, do this problem on the JEE mains and NEET question only. Just to do this. In each row, 10 cells are there. In each row, how many 10 cells are there? 10 cells are there and 10 rows are there. 10 rows are there. Find the current value. It is based on my memory. It is your JEE mains question and NEET question. Both are same standard only. So find the current in the 10 ohm, external resistance. Take your own time and I want answer. Everyone should put sincere efforts, honest efforts. Hundreds of time came in your IIT exam and medical exams. That's what it is. I'm remembering that problem. Simple problem only, you can do it. Ten amperes, huh?
Sir, 10 by 11, sir.
10 by who? I said, take your own time, don't tumble, think freely. I want correct answer, I don't want fast answer.
Hundred by 11.
100 by 11. Ten by 11, huh? Okay, it is my turn, students. Okay, take your own time. No problem. 10 by 11. Huh? Your name, I forgot. Vijayasri. Amma. Amma.
Sir, 10 by
10 by 11. Huh? Primrose also. Okay, it is my turn. Focus only on the any one of the row. All these are in which combo? Series. So net EMF how much? 10 plus 10 plus 10, 10 times. Means how much? 100 volt. Same way, resistors also how many times? 10 times, na? So that also 100 ohm. Like that, every row I can write like this 100 volt and 100 ohm. Like that, how many rows are there? Totally 10 rows are there. This is 100 volt and 10 ohm. And sorry, 100 ohm. This is 10 ohm. Now focus on this parallel combo. What is the net EMF? All are identical cells. All are identical resistors. Net EMF how much? E only, na? This thing you have to remember at your fingertips. If all our identical cells are connected in the parallel combination means net EMF how much? 100 volt only. Yes or no? 100 changing, huh? 5 ampere, huh? Now, what is the net internal resistance? Tell me. 100 ohm, 100 ohm, 100 ohm. All are in, how many are there? 10 resistors are in the parallel combo. What are net internal resistance? R by N, no? In 100 by 10. So, how much only? 10 ohm is there, and this external resistance also we have to write. Now 10 ohm and 10 ohm in which combination? Series. So net current how much? Net EMF by net resistance 10 plus 10 20. 0 cancels out, so 5 ampere. The one and only one girl, Tarani told. Give a big round of applause. Very good job. Okay. That is a very simple problems will come. First time only very difficult student. Regular practice mean every problem will become very much easier. Okay. Now I will give one more problem. Will you try? Find net current in circuit. No haste. Do not excite. Don't feel anxiety. Think freely and give the correct answer. Simple problem only, but some twist is there. It is also your previous year NEET question and JEE question. Based on my memory only, I have given.
Changing the terminals is the twist.
Everyone will feel that it is a, they won't ignore, they won't see that first. Even though if they see that that might be printing mistake, they will feel like that. They will write net EMF how much? 10 plus 10 plus 10 plus 10. How much they will write? 40 by 50, like that they will write. Nicely, option is there. This 4 by 5 will be there in option. So their confidence will double. Nicely, they will select that answer. And finally, after seeing the key response sheet, big biscuit will happen. That is a strategy of framing of NEET question and IIT question. So use your brain 100%, easily you can solve it. If you use your brain, strain will not come. Try all possible methods. Okay, definitely one idea will change. No problem. Minus 2 by 3. Huh? Hmm? 0.5.
So 3 by 4. 3 by 4.